All right. Are you ready? That's a nod. All right, let's do this. So this is my Waffle House talk. This is everything I learned about concurrency and resiliency. I learned at the Waffle House. This is normally a 1-hour talk, just so you know. And to give you an idea of scale, that's 121 slides in 30 minutes. So we're going to be averaging about one slide every 15 seconds. So please don't expect too much breathing room. Let's go. So who am I? You know me. We can talk about it after. Unix stuff, electronics, all that kind of fun stuff. Yes, that is a laser cutter behind me. Next, let's talk about the Waffle House. The Waffle House is a chain of restaurants across the southeast of the United States. That is basically a visualization of where they all are. The tallest one is Atlanta, where, of course, they were founded. So if you actually look at a map of cardiac-related deaths in the United States, do these two look at all similar? Okay, so let's try a little test here. How many data scientists do we have in the room? Well, is this correlation or is this causation? Okay, clearly it's causation because cardiac-related deaths cause Waffle Houses, clearly. So let's get on. So the Waffle House is restaurant engineering perfection. So I want to talk about what would happen if we design software the way that the Waffle House designs their restaurants. So we're going to be talking about software engineering perfection. So welcome to your Waffle Home. For those of you who haven't been there and have never seen it, this is going to be a trip. So let's do this. So first thing you need to know about the Waffle House is the entire enterprise is explicitly designed for quality and consistency, efficiency and resiliency. Everything from the individual restaurant to their entire network. To give you an idea of scale, their SLA for a table service is 8 minutes. So from sitting down to having your food, 8 minutes. Principle number one that drives their restaurant chain. The only software guarantees we have are technical debt and crashes. You should embrace them because you have no choice. You are going to get both of those. I don't care what you use, both of those things are going to happen. So why would a Waffle House software engineering approach embrace crashing? Well, the clue is in the picture behind you, right? Because if you look at the distribution of Waffle Houses, and then you compare it to the distribution of natural disasters, specifically things like hurricanes, you get a general idea that this is something that they're going to be doing a lot of. They're going to be rebuilding restaurants a lot. So let's talk about Carl Fugate, who is a former FEMA administrator. Quote, they're open most of the time, and then there's the Waffle House index. If a Waffle House is closed because there's a disaster, it's bad. We call it red. If they're open but they have a limited menu, that's yellow. If they're green, we're good. Keep going. You haven't found the bad stuff yet. Yes, FEMA actually has a thing called the Waffle House Index, which they use to measure natural disasters. Sean, this is not a good sign. Waffle House in Panama City closes ahead of Hurricane Michael. This is FEMA's worst case scenario. Not only because that is an indication as to how bad the disaster is going to be, but also they get hungry. So who feeds FEMA? The Waffle House. Let's move on. So let's, yes, exactly. Let's design for the unhappy path, or in the case of the Waffle House, the very unhappy path. How do you design for that? Well, like I said, every aspect of the Waffle House operations at every single level of abstraction, from a single order all the way to their entire environment, their entire network, is designed to degrade gracefully in a disaster. So everything fails. So let's start with the obvious. Each Waffle House is a flying spaghetti monster, or more specifically, a finite state machine. So Waffle Houses, like we said earlier, can have one of three states. They can either be green, which is serving a full menu. They can be yellow, which is they're serving a limited menu. Or in this case, I don't think this is a limited menu. I think this is just counter service only. This is more what a limited menu looks like. And then, of course, you have the Waffle House is closed because the Waffle House is closed. So a Waffle House restaurant, an individual restaurant, can actually operate without electricity. It can operate without gas. It can operate without water, which surprises a lot of people because there are legal concerns. And it can also operate without communications. A Waffle House can operate without all of those things. Let me show you how. They have this thing called a storm playbook. And inside of it, and every restaurant has one, they have an individual plan per restaurant. Every single one basically describes how to reconfigure the restaurant for a loss of resources. And importantly, it actually has copies of the permits because, like I said, with no water, they actually have to get variances from the laws because most health laws say you have to have running water in order to operate a restaurant. They actually have references because they prove to the local government that they can operate safely, have food safety without it. And then possibly, arguably, the most important thing, it actually explains how to close the restaurant, because these restaurants are 24/7, 365, so they don't typically know how to close. All right. They have their own meteorological resources. A big part of their model is that they do not outsource because, frankly, they don't trust other suppliers to keep up to their standards. They actually respond to FEMA because they have more visibility into the disaster areas typically than FEMA does, because they have network CCTV that goes back to their headquarters. And they're like, oh, we can't see that restaurant. It's probably really bad. So you get an indication there. Let's talk about what they do when disaster rolls in. So this is an example. This is, I think, Hurricane Michael as it came through. So this is what their predictions said. So what they did was they had jump teams, which are volunteers, Waffle House employees, which are volunteer from across the country. And they staged them in RVs, and they have two teams, one on the east of the path, one on the west of the path. And they basically staged them to come in. The fleet is RVs. They have new food, refrigeration, because of course they can't trust that the restaurant's not going to be flooded, so they can't trust that the food that's there is good. They bring in their own fuel trucks, their own generators, their own propane, and they bring in cash good. The jump team also, with disasters like this, also includes their CEO, COO, and their direct reports. They actually fly their management team in. And the reason they do that is because, oh no, we need $12,000 in order to get this restaurant open. Oh, I need 6 layers of managemental sign-off to do this, but I don't have it. No, sign it. Here's the check. Done. So they can respond very, very quickly because they're empowered. And Waffle House actually flies their people in via private jet because typically, with people flying in and out, it's difficult to get, normal transport in and out. So CCTV cameras, phone numbers, they have all of this stuff in together. It's all taken care of in advance. So let's talk. I think I've already done, here we go. So the purpose of the jump team specifically is to be the people that actually work the restaurants when they reopen them. And the reason that the jump team does it is because it lets the local employees whose houses may have just been destroyed not have to come to work. And by the way, they still continue to pay the local employees, even if they can't show up for work. So, these are my peeps. Menu pricing, to give you an idea of other future planning, they reduce the prices on the menu. The menus are pre-printed, and they actually round everything to the nearest dime, so it reduces the amount of change they have to handle. So it's the little tiny details like this that make a huge difference. So this is what Michael looked like after it went through. You can probably guess what red means. That means the buildings are pretty much no longer there. So how do they respond? Well, when a restaurant is destroyed, all restaurants are identical. So much like we deploy in some environments, we have our gold images. Well, the Waffle House has a yellow image. All Waffle Houses are identical, which is key and awesome because rebuilding is well exercised. And honestly, it is business as usual. Rebuilding a restaurant for them is business as usual. So let's talk about graceful degradation. So if a single restaurant is red, they'll do whatever they need to do in order to provide service back into a region. It's a very simple principle. Your network is more important than a single restaurant. Your application, your service is more important than a single server, right? It's a simple concept that we should all already have. And when there's literally nothing in the area, fleet of food trucks. They just drive them straight in. And this particular food truck, that was where I showed you before. That was in Panama City. And they had no communications because there was no cell phone service as well as no electricity. So what did they do? They fed approximately meals a day, and they gave away for free, everyone for free. This is what they do. Every restaurant, because it comes from a yellow image, has disaster API interfaces by default. They have instrumentation, like I said earlier. They also have things like a dual gas grill. So you can't get natural gas anymore, but you can run on propane. So what do? They stick a propane outlet on the actual outside of the restaurant. So if they need to open a restaurant and there's a gas failure, they just drop a propane tank outside, plug it in, switch it on. They can now operate with gas. So there's a little bit of additional cost for running that extra piping and those extra connectors. But as far, every single restaurant has that. So this is, again, all well exercised, all in all of the original plans. It's all in their gold image or their yellow image, as you might expect. And if they're unable to get their payment systems online, they serve all their food for free because it matters. So, and like I said earlier, employees who can't work because of the emergency are still paid in cash because it's more important for them, for their employees to be safe than it is for them to worry about other little details like profit. One of the reasons they can probably do this is because they're privately owned. They're not actually a publicly traded company. There's a moral in there somewhere. Moving on. So corporate culture, from the top of the company, they prioritize serving their community in a disaster above everything else. And they do lose money in doing this every year. The reason that they do it, I think, is because the founder of the company was actually he did a lot of stuff during World War II, and he was working on the Manhattan Project, basically moving stuff around that had to not be caught. And so he'd seen a lot of things. So this very much, living under nuclear threat was very much a part of his psyche. So he's very much the build the bunker mentality, but that really serves the wider community who have these Waffle Houses. So let's talk about engineering lessons. First of all, said it already, embrace failure because you're going to fail. It's going to suck, but you're going to fail. So embrace it. When thinking of terms of detecting and dealing with errors, think more along the block level than the line level. Now, I'm not going to tell you not to check your return codes. But I'm going to say, if you've got this large application, this large function in an application, and it does like 20 different things in it, and how you would recover from it is exactly the same, no matter which of those 20 things inside actually failed. It's the exact same recovery. Then don't instrument those 20 things. Just let the whole damn thing fail. I mean, that's what it's there for, right? So block. The same plan applies to hurricanes or tornadoes at the store level, right? Are we green, yellow, or red? The same plan also applies to ex-husbands and associates who decide that they want to spend the rest of their life in jail for attempted murder by driving their pickup through the front of the store to try and kill their ex-wife. Yeah, Waffle House, interesting. Yeah, so again, that restaurant's probably red. Also, always have a backup plan in case of the destruction of your Death Star, because you cannot predict every failure condition. So think big. Decouple your dependencies. So like I said, Waffle Houses aren't reliant on water. They're not reliant on gas or telecoms or electricity to operate. So here's the question for you. What dependencies can you remove? That's a very big question for, should we say, people who use Node and NPM. I'm just going to let this slide sit. I'm going to give it an extra like 5 seconds for you to think, do I really need to include that module that right justifies a piece of text because I'm too damn lazy to think about how to solve the problem for myself? Just saying. All right, so let's talk about inside the actual Waffle House itself. How do you make a restaurant more resilient? Well, I'm going to tell you a few secrets here. So I'm also going to burst a few bubbles. So if you don't want to know, this is the time to exit. Orders propagate through a Waffle House differently, very, very differently to any other restaurant that exists because there are no computers. With the exception of the point of sale, there are no computers in the environment. And to be clear, when they take an order and you get your bill, it doesn't show you what is on it. The only thing the point of sale does is that the server will type the amount of money that goes to your credit card, and that's it. It has no visibility of what the actual sales are. It's just an amount of money. Here's the fun bit. The grill operators do not know who or what individual orders they're cooking. So for those of you who are familiar with the web style of the world, you can think of this almost as a separation kind of like form from content like HTML to CSS. They know all of the things. So the grill operator produces all these individual things, and then somehow they are all assembled together neatly, kind of like CSS, right? Except you don't have food, you know, falling out the front door of this restaurant like you would with CSS. Food in less than 8 minutes. All right, so Waffle House does in fact have an IT group, and their motto is keep IT, or keep it simple. Very simple, because you don't get much simpler than not existing. So like I said, no computers. So let's talk about how the workflow works. May I take your order? All right, this is the process. Happy server takes your order, writes it on a check. The check somehow magically works its way to the grill operator who cooks the food, which magically ends up on plates, which magically ends up in front of you. The magic is what we're going to break down. Because the system is designed so it is possible to lose a single thing off your order, but it is impossible for an entire plate to be missed. We've all been in a regular restaurant at least once in our lives, I'm sure, where you've had 6 people at a table and everyone's food comes out except one person, and one person's just like, no, it's really, you guys can all eat. It's okay, it's fine. Yeah, we've all seen that, right? Okay. So let's talk about it. Every Waffle House has a single pair of red tiles as a serialization device. The idea is that the orders are actually called verbally from the server to the cook. But here's the important thing. The checks don't physically move. So in a normal restaurant, which doesn't have a computer, they would hand over the physical check to the cook, and the cook would look at the check and they'd be like, oh, I need this, this, and this, and this. And they'd have to time everything, right? This isn't necessary here. So these red tiles work as a serialization device because it's not possible for 2 humans to be in the same physical space. So we're using the laws of physics. So we want all plates to arrive at the table at the same time. And since different items have different cook times, how do we do that? We instruct the cooks to drop the longer cook times first, and then all identical items at the same time. It's really, really simple. So let's look at the check. Those of you who are into model versus presentation, this thing will be like a ding, that's so simple. This is how it works. Columns represent customers. Rows represent kinds of food. And the top, what we do here is we lay out the same groups of items together. So for example, in this check, plate number 2 actually has a double serving of hash browns, and plate number 3 has hash browns which are smothered and covered. So the layout of the check actually groups the individual things together, which is actually kind of cool. Let's look at the top. The top row is for grouping meats. So what's smart about that is that steak takes the longest amount of time to cook, so it's called first. Quarter pounder takes the next amount of time to cook, so it's called second. Bacon, 1.5 bacon, takes the least amount of time, so it's called third. Make sense? So bacon is 3 strips. So what they do is when they take your order, they only take it on the bottom part, and then they basically transpose all of this up to the top. So you can see it moves from the bottom to the top. This is almost like a presentation layer here, if you see what's going on here. All right. So the check isn't passed because they've separated content from form. And this is the abstraction. If the cook doesn't need to know who gets what onto which plate and what seat at what table, don't give that information to the cook because it's only going to confuse them. It's kind of logical. So there. So this is how it works. Red associate steps onto the red tile. They have a common API. Their API is a language. Pull means the top word. Pull 1 sirloin medium rare, 1/4, 1.5 bacon. Drop hash browns on 3, so dropping 3 hash browns, with 1 smothered covered. So you see what this is? This is basically, for want of a better description, it's a DSL for a restaurant communication. So the sales associate actually watches the grill operator place each item on the grill, so they know, so they don't actually call the next one until the previous item is on the grill, which means A, it's cooking, and B, they know it's not lost. So that is a synchronous communication. And it also creates back pressure because no new requests can go onto the grill until each of these items is placed in order. It's really simple, but it's back pressure, which, you know, saves the things. So meat and hash browns are cooking. How does the form state from the check get applied to the food? So how do they know which of these now completely separate things on the grill, which belong to, you know, maybe 5 or 6 different tables and 20 different people, how do they know which plates to assemble them on? Well, they call it out. This is the CSS of Waffle House. Mark steak medium rare, plate smothered covered, order over medium, bacon quarter deluxe, double plate, chocolate waffle. On the side, 1 bacon. So this language allows them to basically announce verbally where these things go, but it doesn't go to the cook. It's a different actor. And it's true, this is still more human readable than XML. I mean, am I lying? All right, so where is the state? Where does the state actually exist? Where is this state stored? So I'm gonna show you something now that, all right. Do you ever wonder why a waffle comes with a side of butter and mayonnaise? I mean, who really would eat mayonnaise on a waffle, right? Well, during the mark, somebody actually encodes the form state on the individual plates, and it looks like this. How cool is that? They have an entire encoding system on the plates, which means they never need to pass a physical ticket. So let's look at this. No civilized person uses ketchup on a steak, right? It's therefore encoding the steak and how the steak is cooked, not to be eaten. No civilized person eats their eggs with jam or jelly. Again, it's used for encoding. So sunny side up, basted, over light, over medium, over well, poached and scrambled. Simple stuff. No civilized person eats their meat candy with pickles. Do you want it plain? Do you want ham? Do you want sausage? Do you want bacon? It's the location of where they put the pickles on the plate. So when the item is ready, and remember all the items become ready at the same time, the cook-op just pulls the hash brown off the grill, looks down the line of plates and drops it on the plate. Boom, done. And again, because they're filled in order, everything fills on time. So what happens if you make a mistake or you're still hungry? Well, once you've called it, it never changes. So let's say you want to change your order, you want to get a new ticket, and you throw the old one away, and you want more food, you get another ticket, because all data, all food in this restaurant is immutable. Yes, the Waffle House is functional. It's a functionally programmed restaurant. So here's our engineering lessons. We do have back pressure created by the red tile. 2 physical people cannot call orders at the same time because they cannot physically stand in the same place. When state is transferred, it is done synchronously. The person calling the order sees the food dropped, and then they continue with the next thing. When data is returned, in other words, the food gets dropped on the plate, it's returned asynchronously. The grill op just grabs the food and drops it on the plate and just continues doing their own thing. And content and form are separated both in storage and in communication. And that is really important from an engineering standpoint. And we can talk in more detail when we have more than 30 minutes. Decouple all of your sub-processes from each other so they can run independently and in parallel. All of these individuals are operating independently. The only time that they actually interact is when they communicate. This is all message passing, and it's only for a short period of time. And again, checks in food are immutable. Once they're made, they can never change. So let's talk about a computery example. We've all done this, I'm sure. We query from 3 systems data. We collate and manipulate the data in some form, and then we return the data to the requester, right? Anyone who's ever written an API, I'm sure, has done this 1,000 times. So we run 3 queries, yay, we collate the responses, and yay, we return the data to whoever the requester is. Okay, we've all done this 1,000 times. So let's look at how you do it from the Waffle House point of view. you would create a separate process to manage this request. It already knows what the queries are and who the data should be returned to. That process is a plate. This means that the server, in other words, your web server or whatever, can go ahead and, deal with servicing, other incoming requests, because anytime an incoming request comes in, the only thing it does is create a plate, do stuff with, drop the plate on the table and it's done. So we create 3 independent processes to execute our queries. So we're going to have a steak process, a steak database, and a pork chop database, and a bacon database. And by the way, they plate themselves. That's also important because you don't want stuff blocking. The plate notifies the requester it's ready to be picked up. The requester picks the plate up and gives it back to the user. So it's all about reducing the amount of time that you are blocking by having individual actors. Individual actors have individual threads, which means that you just don't get contention. None. So what if things go wrong? Well, what's our worst case scenario? Our worst case scenario is probably no bacon. I think most of us would agree. There's no response from the bacon database. Well, so how do most APIs, when you go out in the wild, actually deal with this? Well, let's talk. So your API says, give me steak, pork chops, and bacon, and the connection just hangs, right? Give me steak, pork chops, and bacon, please, and just hangs. Give me steak, pork chops, and bacon, please, and connection hangs. So what do we as API users do? We just keep asking and asking and asking, right? So meanwhile, in the kitchen, this is what happens. All of those things are still going on. The back end just collapses and boom, you've hit critical mass, your entire service dies. And now you've got a throttle incoming so you can try and bring yourself up in an orderly fashion. I'm sure none of our applications do this anymore, but I'm sure we've all seen it. But because we structured our application to be non-blocking and non-serialized, we could do an asynchronous API where we can say, where's my data? And it'll respond, well, I'm still waiting for bacon. Which means that the business side of the house can actually say, instead of waiting for that bacon, I can say, well, I don't really need that bacon for my main business. That's like a little decoration on the side of the window or something. We can go ahead and serve all of the data the user wants straight away, right? And they can come back for later, which means you give your application writers the opportunity to degrade gracefully. These things matter. So give me what you got. All right, so where's my data pending bacon? Give me steak, pork chops, and bacon. Again, ad infinitum. And because they make 4 identical requests, you don't need to kick off that bacon request multiple times because you know it's already running. So if you want to be fun, you can just return 4 copies of the bacon to all 4, and then the application person can do, why did I do that? And then you've taught them a valuable lesson. Moving on. So my final thoughts. If you take anything away from this talk, please remember the Waffle House is a highly resilient, distributed, redundant, containerized, functionally reactive, supervised network of restaurants that are fully decoupled at every layer of abstraction by strongly typed, isolated actors that communicate only via message passing with no shared state. Orders are type checked for valid data and dispatched lazily and asynchronously via message passing. The messages consist of semi-groups of null functions created by partial application and then finally lifted via applicative functors, resulting in a perfectly cooked meal. Remember, everyone, the bacon is idempotent, which means you can eat as much of it as you want. So please assume failure. You won't be disappointed. Write asynchronous APIs. They provide opportunity for back pressure, instrumentation, protection of your back-end resources, deduplication of effort, and you get to push choices to your client. Decouple everything. Consider your dependencies. Consider dependencies as a dirty word. That's the big thing. Consider dependencies a dirty word. Thank you.
I just realized I was muted while I was clapping. Yay!
Thank you. And that was within 30 minutes. My gosh.
That was amazing. I also did not realize that Waffle House had so much like so much of an like API, I guess, for lack of a better word, for all the orders and everything. That was incredible.
A lot of people think that the cooks actually memorize the things because they see the servers call the orders in verbally, but they never see the cooks write anything down. And then they see the cooks drop the food onto the correct plates. People think that, oh my God, these people must have amazing memories. But they cheat a little, just a little.
They have a
And that's
framework.
and that's okay.
Yeah. Man, that was amazing.
Yeah.